Okay, we're going to take some derivatives in 2.4. I'm calling it assignment 2.4a because I'm probably going to add some afterwards. This is just a minimal assignment from 2.4. Chain rules essential, so I don't want to proceed till we get this pretty well mastered. So I want to find the derivative, dy dx. You're going to do power times base to the 1 less power, but now times the derivative of the base. The derivative of the base happens to be 2. So the derivative is going to equal 6. 2 times 3 is 6, times 2x minus 7 to the second power. And that would be your answer for that one. How about here, g prime of x? Keep your 3 out front as a constant factor. Power is 4. The base is 4 minus 9x. To the 1 less power would be 3 times the derivative of this base, which is negative 9. 0 minus 9. So 3 times 4 is 12, times 9 is 108, but I believe there's a negative. So it might be negative 108 times 4 minus 9x quantity to the third. Now many of them, it's to your advantage to rewrite it before you take the derivative. For this, for example, you might want to write as an exponent, power over root. The power is 1, the root is 2. So it is, a square root is a 1/2 power. So let's find the derivative by doing the chain rule. Power times base to the 1 less power times the derivative of the base. The derivative of the base is negative 1, or 0 minus 1. So what do we have? We have a 1 over a 2, but I think it's negative, right? And this means the square root on the bottom. Okay, 7, 9, 11. Let's try 17. Here's another one I would probably rewrite first. I would probably rewrite it as this to the negative 1. So if I took its derivative, I would do power times base to the 1 less power. Very conveniently, this time the derivative of the base is 1. So what does this become? Negative 1 over this quantity squared. 21 is another one I would probably rewrite. I would probably call it 3x plus 5 to the negative 1/2. To find its derivative, I would do power times base to the 1 less power times the derivative of the base, which I think is just 3. So you get negative 3/2, 3 times 1/2, and there's a negative. And then you have 3x plus 5 to the 3/2. Now that would be the derivative. The only problem might be it's not in radical form like the question was asking. So how could we write this in radical form? Well, you could write it as this. Let me just write it. Power over root. What root would you have? It would be a square root of this to what power? 3x plus 5 to the third. Let me see how they leave their answer. So apparently the textbook has this bottom answer because they want it in terms of radicals because the question was expressed in terms of radicals. Now if we move on to 23, I think I'll guarantee one of these type on your next quiz. Okay, 23, like I said, I would probably ask you something similar to this. Yes, I am going to ask you to factor your answer as I'm going to do. We're going to do a product rule. I'll bring the x squared down. times the derivative of this, which is power, times base, to the 1 less power times the derivative of the base, which happens to be 1. Then I would bring down the x minus 2 to the 4th times what's the derivative of x squared? 2x. So what did I do here? I did a product rule. U times v. Its derivative is u v prime plus v u prime. Now let's rewrite this. 4x squared times x minus 2 to the 3rd. 4x squared minus x minus 2 to the 3rd. This would be plus 2x times x minus 2 to the 4th. Just let me double check that I wrote it correctly, and I think I did. Now we're going to factor it. Would you agree that 4 is 2 squared and 2 is 2 to the 1st? Which is the least power? 2 to the 2 or 2 to the 1? 2 to the 1. So that's what I'm going to factor out, is I'm going to factor out a 2 to the 1st. Which is a smaller power of x? X to the 2 or x to the 1? X to the 1. So that's what I'm going to factor out. How about x minus 2 to the 3 or x minus 2 to the 4, which is a smaller power? X minus 2 to the 3rd. So that's what I'm going to factor out, an x minus 2 to the 3rd. Now, there's a plus here, and we're going to fill in what goes in here. 2x times what is 4x squared? Because you already have this part. 2x times what is 4x squared? Well, that'd be a 2x. 2x times what gives me this? Well, I already have the 2x. What do I need? Another x minus 2. So what does this become? 2x, x minus 2 to the 3rd, and this is 3x minus 2. So that's going to be your derivative. I find some people struggle on the factoring. If that's the case, then factoring on 25 is going to be a little more challenging because they're fractional exponents. Number 25 is another product, so I'm going to do another product rule. I am going to realize, however, that the square root could be written as the 1/2 power. So when I do the derivative using a product rule, I'll bring the x down times the derivative of this part, which is power times base to the 1 less power, but times the derivative of the base, which is negative 2x, plus bring the radical part down, so I bring down this to the 1/2, times what's the derivative of x? 1. So when I rewrite this, very conveniently, 2 times 1/2 multiply to give me 1. A negative x times x, I think, is negative x squared. And you'd have 1 minus x squared to the negative 1/2. This would be 1 minus x squared to the positive 1/2. Let me just look. That looks correct. Now I'm going to factor out. So, x to the 2 or x to the 0, which is the smaller power? X to the 0, which is 1. So really, I can only factor out the smallest power of this. So to the negative 1/2 or to the positive 1/2, which is a smaller power? Negative 1/2. So that's what I'm going to factor out, is this to the negative 1/2. If you took this part out, what would remain? You factored that out here, so what would remain? I think negative x squared. If you multiply these, would you get this? Yes. Now, what do you need over here to make it to the 1/2 power? You need it to the 1, because -1/2 plus 1 is 1/2. Remember, when you multiply, you add exponents. If you'd rather think of division and subtracting exponents, that's fine. What's 1/2 minus -1/2? Still 1, right? So anyway, what does this become? This is 1 minus x squared to the -1/2. This would be 1 minus 2x squared. So your answer is going to be this over the square root of this. And that's what I should have for dy dx. Okay, 23, 25, 43. We want the slope at this point. So that means I want the derivative. The derivative of e to a power is e to the same power times the derivative of the power. So first thing is I find the derivative. Now I want to put in the x value that they're talking about. So I have e to the x, and what is my x? E to the 0. So the slope of the tangent line at that point would be 1. Basically, you just take the derivative and put in the x value. It says find the slope of the tangent line to the graph of the function at the indicated point. So that's what I just did. Again, the derivative of e to the u. If I had a derivative of e to the u, it's e to the u times u prime. The derivative of natural log of u is 1 over u times u prime. So what's this derivative going to be? 1 over u times u prime. If you simplify that, it should become just 3 over x. So I believe this becomes 3 over x for its derivative. Now, if you were to put in the x value that they give us, the x value here is 1. So what's the slope of the tangent line for this curve? 3. From here, I think I'm jumping to some trigs. Yeah, it looks right. So the derivative of cosine of u, derivative of cosine is negative sine times u prime. So basically, the derivative of cosine is negative sine of the same angle times the derivative of the angle. So your answer would be negative 5 sine of 5x. 53 is a little harder. It's a product, so you need the product rule. U times v would be u v prime plus v u prime. So let's do that. I'm going to bring the sine of 3x down. The derivative of cosine is negative sine of the same angle times the derivative of the angle. Now I'm going to bring the cosine part down, which is the v, times u prime. The derivative of sine would be cosine of the same angle times the derivative of the angle, which is 3. The only thing I'm going to do from here is I'm going to rewrite this as negative 3 sine 3x. Looks like sine squared 3x, doesn't it? Plus 3, looks like it would be cosine squared of 3x. You might just rearrange it, put the positive first, then minus this because it says negative. The only thing I could see doing is maybe factoring a 3 out. Something like that. Okay, some other problems might be like 13. First, I'd rewrite this as 6x squared plus 1 to the 1/3 power. Now I'll find the derivative, so I'll do power times base to the 1 less power times the derivative of the base. The derivative of the base is 12x. 12x times 1/3 is 4x. This would be 6x squared plus 1 to the 2/3. So you'd have 6x squared plus 1. Let me put it like this, and write it as power over root. So what's the root? The third root, and what's the power? 2. So the book is probably going to have 4x over the third root of this quantity squared. Okay, for 15, I would rewrite this as 2 times 9 minus x squared to the power over root. Fourth root is a 1/4 power. Now I'll take the derivative. That's why I'm writing dy dx. Then you're going to write power times base to the 1 less power times the derivative of the base. 4/4 less than 1/4 is negative 3/4. The derivative of this is negative 2x. So what's 2 times 2? 4. 4 times 1/4 is 1. So I think you simply have a negative x and a 9 minus x squared to the 3/2 on the bottom, which is a negative x. And again, it's power over root. So what's the root? It's a square root of 9. Let me use parentheses. Of 9 minus x squared to the 3rd. Hopefully that's the answer. Let me just take a look. I apologize. It is a 3/4 power. So this would be on the bottom to the 3/4. So it is the 4th root and the 3rd power. So that looks better for 15.